Wouldn't it be nice if you could restrict the amount of characters a string is allowed to have in certain scenarios? And if TypeScript would throw a compile time error if the string does not fit the restrictions you applied? In this video, we will do exactly that. We will create some types which you then can use in your code to immediately get a compile time error when you pass strings which don't fit the restrictions. Let's get started. So before we can get started to implement our real types, we need to create some helper types, which we will then use in the other ones we will create later. So the first helper type is the length type. But why is this important? The length type will help us to determine how many characters are in a string. So how can we do this? Well, the first thing is let's create a type and let's call this type length. Now the first argument of this generic type is t, which has to extend string. And the second argument is an inferred type, which we will not pass in ourselves, but it will be used when we recursively call our length type here. So I call this type counter, and this is of type array. So we say extends number array. And because I don't want to add an empty array every time I call this length type, I just say if I don't pass in a type for this counter, it's always an empty array. So now let's implement this type. And what we will do here is we will implement this type recursively. So as long as there are characters in our t type we pass in here, we will again call our length type and add one more element to our counter array. Because that way, as soon as there are no more elements in our t type we pass in here, we can just return the length of our counter array to get the length of our string. But let me show you how this works. So the first thing is we say if t extends, and then we use template literals here to extract the first character of our string here. So we say $sign and with the curly braces, and we say string in here, and there is a tail. So we say infer tail here. So what this template literal here does is it checks if there is still a character in here followed by any other string. And this tail here could also be an empty string. As long as we still have characters in there, we want to do certain things. And what we will do in this case is we will just call length again with our tail, because we don't want to call it with the complete string again, because this will be an endless loop. So we say tail here, and as a second argument, we just create a new type array and we spread our existing elements from our counter into it, and we add another element to it. Now by using this approach, we remove the first character of our remaining string and we add another element to our counter so that we keep track of how many elements we already passed in our string. Now if there are no more elements in our string, what we will do in this case is we just return counter length. Now this counter length has the number in there, how many elements are in this type array. Let's see if this works. We create a new type here, test, and what we will do is we say length and we say, for example, hello. And when we now check the type here, we can see we get back 5. If I change this, for example, to hi, we can see I get back 2. So with this helper type, we already get back the length of our type. Now we can use this length type here to create our second helper type, the compare type. So let's create this here. So the first thing is we create a new type and we say compare. And this takes two arguments. We have a first, which extends number, and we have a second, which also extends number. Now, as before with the length, we also need a counter again, and we will see why we need this. So we say counter, and we say this extends number array, and it starts with an empty array to start with. Now, let's first say this is of type any, because I want to show you how we will implement this compare type to make this work. Let's say we call this compare type like this. We have compare 1 and 2 like this. Now, what we want to do is we want to figure out which type here, the first one here, or the second one here, is reached first when we add more elements to our counter. So we want to figure out if the first type here or the second one here is reached first. So what we will do to achieve this is we will just increase our counter, and we will always check, okay, is the first one equal to our counter or is the second one equal to our counter? Because if the first one reaches our counter, we can immediately turn the string less, because this means we have not reached the second type here. So this means the first one is less than the second one. And the same is with the second here. We will check if we first reach the second type. This means that the first one here is larger than the second one. But let me show you how this works when we implement this. So the first thing we do is we check if first is the same as second, because this would mean they are equal. So we say first extends second, in this case, we return equal like this. Now, if this is not the case, we have to check if counter is the same as first or second. So let's move this on a new line here. And let's say if counter length extends first, this means that the first type here is smaller than the second one. So what we will do here is, in this case, we return less. Now let's think again why this is the case. Because when this here is true, we immediately return less. So this means that the second type we have here was not reached by our counter. So this means that the second one has to be larger than the first. Otherwise, what we do is we check if counter length extends second, because this then means that the second type is reached before the first type. So as a conclusion, this means that the first type is larger than the second type. So we say here greater. Now we have done all the checks, but what if none of these is true? Because at the start, our counter here is at 0. So 1 is not equal to 0 and 2 is also not equal to 0. So this means we have to call our compare type again. So we call compare here again, pass our first and we pass our second here. And we also create a new array like we did with the length type, and we just spread our existing counter into it and we add another element to it. Now let's close this here and we are done with our compare type. So let's see if this works. So let's create a type here test and we call it with compare 1 and 2 like this. And let's see what the result here is. And we can see less because 1 is less than 2. Now when I change this here to 2, we can see we get back equal. Now when I change this to 3, we can see greater. So this works exactly as we want, because now we have basically like a type function which returns to us if the first argument is equal, less or greater than the second argument. And now we have already created the two helper types we need, and we can start to use them in our real types. And the cool thing about these helper types is that now our real types are really easy to write. So let's remove this here and let's just create our first type. Let's create the type MaxLength here, and we pass in this t, which has to be a string. And we also pass in a max, which has to be a number. Now, what will be the implementation? The implementation is really simple because we just call compare here and we pass in here the length of our t as a first argument, and we pass max as our second argument. And now we can say if this compare call extends less or equal, in this case we return t itself, otherwise we return never. Now why does this work? Because compare here will return less or equal if this length of this type we have here is smaller than max. And because of that we can say, okay, as long as the first argument here is smaller or has the same length as this max, we want to return t. Otherwise, we want to return never, because the never type we can then use in our function so that we can get a compile time error. But I will show you this in a minute. So let me now show you how you can also implement this for MinLength. So we copy this here and let's paste this in here. Now, the first thing we have to change here, of course, is the type name. So we change this to MinLength and we change this from max to min like this. Now, of course, currently this would be wrong because we are comparing the length to min, but we can just turn this around. We can say, well, now min is the first argument and the second argument is our length t here, because now we are comparing if min is smaller or equal to length, and in this case we return t, otherwise we return never. So we have now the max length and the min length, and now we can create really easy this InRange type so that we have a min and a max and the string length has to be in this range. So let me scroll up here a little bit and let's create a new type here. Let's create this type InRange and we pass still this t, which extends string, and we pass a min which extends number, and we have a max which also extends number. Now the implementation for this is really simple. We need to just check if min length is okay and max length is okay. So we say min length here, and as a first argument we just pass in our t, and as our min parameter we just pass in the min we have in our InRange type. And now what we do is we create an intersection type. So we say we want to have an intersection of min length and max length, and we pass in this t and we pass in the max type here. Why does this work? If one of these two types return never, the whole type will be never, because never is the most specific type in TypeScript. So this means if I have a type here and we have our never test here and we say 1 and never, never, we can see that the type we have from this is never. So it will remove everything which is less specific than this never type, and the never type is the most specific type. So this means that if MinLength or MaxLength are returning never, the whole type will be never. So because of that, this makes it really easy to create this InRange type by just calling MinLength and MaxLength and using an intersection type. So now we have created these types. So let's now create the real function implementation, and let me show you how we can use these three types in a real function. Let's remove this here and let's scroll up here a little bit. Now what we will do is let's first create a function, and let's call this function max or throw. And we will make this a generic function. But what we will first do is we will not use these types, but we'll just create a pure function which does not use max length, min length, and InRange, because I want to show you what the issue with this is. So let's say we have here a string we pass, which is of type string, and we have this max, which is of type number. Now this will return a string, and we say, well, if the string length we have here is greater than max, in this case, we throw new error, and we say here, well, the string is too long. Now, if this is not the case, we just return string like this. Now, the issue with this is that we don't have compile time safety. Now, let's say we have our max or throw here, we have our hello, and I say the max length is 1. Now, I can, of course, run this code, and we can see here I get an error at runtime, hello is too long. But the issue with this is that I don't get a compile time error. Now, this is exactly why we created these types, because now we can add them to our function. So what we do here is we make this max or throw here generic. So the first thing is let's put these arguments on a new line here, and we say we have this t we pass in, which extends string, and we have max, which extends number here. Now, what we do is we say this max here is no longer of type number, but this is this max generic here we pass in, and this string here now is not this t we pass in, but this is this max length type, which we also pass this t, and we pass our max generic type here we pass in our function. And now you maybe have already spotted it. We now have a compile time error here because this hello here is too long. Now when I hover over this, as you can see, argument of type hello is not assignable to parameter of type never. Let's backtrack what happened here. This hello string here will get passed as this t. Now this t here gets passed to our max length type, and in here, because we check for the max length, this will return never if the type we pass in is not less or equal than this max we also pass in here. Because of that, this will result in this max length here being of type never. And because string is not assignable to never, this will not work. So we can see here we now get a compile time error, but as soon as I change this from 1 to 10, this works as expected. Now, of course, you could do the same with the min length, but I will not do this here in code because this is the same you would also do with max or throw, just the other way around. But of course, you can find the code in the description below on my GitHub. But what I will do is I will implement the InRange function. So let me just copy this here and paste this in. And now we just replace this max with InRange. And of course, what you now also need is a min. So we add a min extends number here. And now here, instead of max length, we pass in range, pass in here our second argument with the min. And we also add here a min, which is of type min. And now we just say if the string length is greater than max, then say string is too long. And we say else if string.length is smaller than min, then we just throw also an error. So let's just copy this here, paste this in here and say too short. Now let's scroll down here and let's see if this works. We just replace max or throw with InRange or throw, and we pass in, for example, a 4, and we can see here this works perfectly fine. But as soon as I, for example, say this has to be at least of range 6, we can see we get an error here because hello is only 5 characters, but we need 6 here. Now, as soon as I change this, for example, to a 1 again, this works again. But when I change the max here to 4, this will also not work because, as you can see, now the input is too long. Now, an important thing to understand here is that this only provides compile time safety when we pass strings, which can be determined how long they are at the beginning. So for example, when I say here let a is equal to test, and I pass this in here, then this will throw an error. Because as we check here, we can see this is just a string and cannot be determined if it has an exact length. So this means we can only pass in const in here, because TypeScript can now figure out that this will not change, and it can determine that this is exactly of type test. This is of course not a silver bullet, so always make sure that you also have runtime checks in place. So here, for example, we will throw an error if this is not the case. Always make sure that you have a real safety net when you run your JavaScript code without TypeScript types. But I think this is really cool, for example, for domain-specific languages or for other stuff where you want to restrict your strings so that you cannot pass in something which is too long. For example, when you have like a name field which you only want to have the length of 30 characters, for example, then you can add this type additionally to other checks, for example with SOT, to help the developer during development to prevent some obvious mistakes. So thank you for watching the video. I hope you learned something useful today. If you did, please leave a like and subscribe to the channel to stay up to date for the newest TypeScript stuff. And also let me know in the comments what kind of topics you'd like to have covered in future videos. See you in the next one. Bye.